Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about background processes. So this is the big picture of Oracle database server. So which is consist of SGA and then so this is with term this was an instance and this is the file system, and then we have already discussed in detail about what kind of different files that consist of the database, how this SGA is allocated, and then what are different types of pools and all this thing. So in this next set of videos, what we're going to do, we're going to discuss about all these processes. So now let's say how do I know what are my background processes that is running right now. There are two ways you can know them. So let's say for example your SID is ORCL. So if your SID is ORCL, go to your Unix command line prompt and then give the following command, which is ps-ef grep ORCL. So if you do this ps-ef grep ORCL, it is going to show all your processes that is running right now on your Unix server, and those are basically some of those processes are background processes. Like you probably will see something dot underscore SMON underscore PMON. Okay, so those are the background processes. The second way is to look at a table called $bg process. Okay, so by querying from a table called $bg processes, you can figure out what are the database processes that is running right now. So to basically show that thing, I have already done that one in my Unix system, and this is what I got. So on my database system, if I do select p address name description from $bg process, where p address is not like 00, then it will show me 12 rows. That means I have 12 background processes that is running right now, and it shows all these different background processes, like this is PMON, this is dbwr, db writer, and so on. So and then, but if you do not give this condition, then you will see from $bg processes maybe 145 rows. So that means we can potentially configure all these things to run for the database background processes. Okay, so but here in this case I just configure only 12 of them. And then now let's saw this is whatever we saw this thing, you can visualize in a schematic way, and I have taken this one from the Oracle reference documentation, and then so these are different processes, and then so these are the file system, this is the memory structure, and then these are the background processes. So in this video we are going to discuss about all these three top background processes. Okay, and then next videos we are going to cover these three or this four, and then that is how we are going to complete our lessons on background processes. So let's try to understand what they do and then know why they are there in the first place. So the first one is PMON, okay, or called process monitor. So process monitor does following things. One is that it is going to clean. So let's say for example you are you are somebody is running on your database. So that means is connected to a SQL Plus client, and then what happens is that for whatever reason this connection is broken. Okay, so then what we are going to do, we are going to have this client must have a dedicated server process running on behalf of him. So if this connection is gone, then somebody needs to clean up this dedicated server process because it's not required anymore. And then this user might have stored something on the SGA, on the SQL area, and so on. Then PMON job is to see, like if there is any process which is is limbo or is not doing anything. Okay, or so those processes is going to be cleaned up by PMON. And then while cleaning up, let's say it when this connection disconnected, it might have started a transaction but it has not either committed or rolled back. Then PMON is going to roll back that transaction. Okay, and number two job of PMON, so is to see, like, there are other processes are running, right? Other background processes are running, and check, like, if those processes are running fine or not. If for whatever reason some processes got crashed, then PMON is going to recreate them. Okay, so PMON basically monitor other background process and restart in case of a crash. In case of crash. So number 3 job that PMON does, if it says, for example, for whatever reason it detect that there is a problem with the redo buffer, and redo buffer in the redo log, let's say there is a process called log writer who's going to write from the buffer to the log files. So for whatever reason, if PMON detects that log writer is not doing the job, that is a serious problem, and then it should shut down the database. Okay, so if shut down the database in case of PMON detects there is a serious problem that is currently going on inside the database. Okay, so the next thing is SMON. So SMON does a couple of things, like it is called system monitor. It coalesces. Okay, so it coalesces free spaces. Okay, so what does it mean? Let's say we have, this is our, if you remember, we discussed about our segment extent and all this thing, right? So let's say these are the, there are 2 extents allocated, and for whatever reason we are going to delete, and then we are going to remove, we are going to free the space. So whenever SMON is going to detect that is this is a, a free extent, and then nearby there's another free extent that is also available, then it's going to collate together to make a bigger extent. So it's going to coalesce this free space and then make a bigger extent, so that, so later on this big extent can be allocated. Okay, so therefore, like, so for example, we are keep deleting from our employee table, so that means we are freeing up the, blocks, and that means, some part of the blocks is, some part of the extent is filled, and then somebody else is doing just near, neighboring extent, somebody is also deleting something, then SMON is going to detect those things and coalesce those things to create a bigger extent, so that that extent can be allocated at some point of time. Okay, so number 2 is, whenever we're going to delete, there are two tables, two very lower level system table called object dollar, and so this object dollar, right? So this lower level table contains all those things, but whenever you're going to delete those things, it may not happen that in the lower level level tables that things got deleted. It may happen that the low level things tables can contain those rows. System1 is going to clean those things. Number 3, like, when we have undo segment or redo segment, right? So sorry, we have rollback concept, so we have not taught it so far, but we are going to deal it later. So whenever we have, in the rollback segment grows automatically. Okay, so what this SMON is going to do, if we have deleted something, if you do not need any information on the rollback segment, then it is going to go on and shrink the rollback segment. Okay, so these are the couple of things that SMON is going to provide, and then these are the, 3 things. Maybe there are a lot more, and then maybe if you, whenever you need those things, you might, you might need to go and then read the book, so that you will understand, like, what are the other things that SMON can do. The last process is called RECO, or recoverer. Okay, so this process is used in the 2-phase commit. So let's try to understand what is 2-phase commit. Let's say this is a database, and this is another, in a distributed system, so we have multiple databases, right? Let's say one transaction is initiated from this database, so this is called coordinator. So this is where the transaction starts, right? But this is a distributed transaction, so we just to make sure that this is all, basically, let's say this is all depend on this D2 and D3. Okay, so that means we cannot commit unless and until all these things are committed. So in that case, what we are going to do, this coordinator who is going to start the distributed transaction, it will ask the other parties if they are ready, if they are ready to commit. And then all these nodes, they are going to say that yes or no. If they say no, then this is going to roll back. But if they say yes, that we are ready to commit, then all this thing will notify to this coordinator that well, we are yes, we are ready to commit. When they notify that we are ready to commit, then this is called prepared state. That means all this coordinator D2 and D3, they move to the prepared state, means they are ready to commit the transaction. And when they are in the prepared state, after they gone to the prepared state, the next step is to say commit. So this will commit, this will commit, this will commit, and then this coordinator is going to wait for their response that they are actually committed. So this is two-phase commit. Phase 1 is prepared state, phase 2 is actual commit happens. But what happens if during after the prepared state, this guy is going to say to D2 now commit, and it waits for the response if he has committed or not. If during that time the network connection between these two is disrupted, that means this is waiting, this coordinator is waiting for for D2 to say if he has committed or not. Since it didn't get back anything, then it's just going to wait for them. Then comes the recover process, is comes in and then check, like if there is if there are some transaction which are two-phase transactions which is waiting which is in the prepared state but never committed. So let's say that there may be two cases, maybe after some time, so now RECO process is going to take over this transaction, and it can either commit or roll back depending upon if it, let's say for example, it may happen that after some time the network connection is re-established, right? And then recover process is going to check if the other process D2 or D3, other database D2 and D3, they are actually committed or not. If they have committed, then all this thing, so it will do a commit here in this coordinator. If not, then it's going to do a rollback. So that means RECO process is going to, in case of a two-phase transaction in a prepared state, recover process is going to take care of those transactions, and then either it will commit or roll back.